So here we have a Hydron geothermal heat pump. This one is burning the 5 amp fuse here. This fuse is for the control circuit, the power that runs up to the thermostat and all that. When it tries to bring on the compressor, he's saying that's when it actually burns the fuse. Because he said the fan runs, everything runs fine, but when he switches it into cooling, suddenly, boop, burns that fuse out. So I'm guessing that it has something to do with this part of the circuitry. This contactor right here is likely what brings on our compressor, and everything else is probably cycled by this little board here. So we could just preemptively change that out, or we can try it once and observe what it's doing, but that's obviously going to cost us a fuse, so just have to decide what we want to do there. Right now he's just got the fan set to on, and this is our thermostat wiring connections, so we can actually jumper from R to Y1, and that will bring on the cooling circuit. I think we are going to do that just to observe what it's doing. Just insert this jumper in here and this one here. Okay, so we got that jumpered. It wasn't jumpered before. Drawing 0.9 amps, which probably nothing. Okay, so compressor started right up. You can see our pumps are running. This is the flow indicator. Jumped up to here. Running about 14.25 gallons per minute. That's not what I was expecting to happen. I was expecting it to blow that fuse. You can see we're drawing 0.1 amps on the contactor there. Let's read our voltage coming in and going out on the switched contacts. We got 240. And then we've got 240. What in the world? 6.8 volts coming from this transformer. So that looks reasonable. I don't really see any damaged wire or anything like that. So jumpered at second stage cooling, and we'll see what happens this time. You can hear the fan is ramping up a lot faster than it was before. Loose. So any one of these wires had rubbed through for the thermostat or anything like that, that would be a cause of concern, but everything looks really good. So this is the compartment that would house the compressor and stuff. We've got our lines that go out to the loop field. So these carry heat away, or they carry, you know, the cool water from out in the field, depending on if you're heating or cooling with the system. Typically these are set up with like a large coil right here that pulls the air from the house through, and then the blower and stuff would be there. These go out to his loop field, which goes right out this way. I just went and switched cool on in the upstairs from the thermostat to see if that makes a difference. Rather than jumpering it here, if there was something wrong in the thermostat, perhaps when it cycled the cooling on, it could be blowing the fuse for some reason, but I don't know. It's not obvious to me. I think we are going to replace the contactor, because it's the only... What in the world? Okay, so it just burned the fuse. Weird. That's really weird. Okay, so when I turned it on with the thermostat, you saw it burn the fuse. Well, I disconnected the contactor coil and plugged it in here. Went upstairs, cycled it back into cooling. It took a little while for it to actually bring on the contactor again. But when it snapped in the new contactor this time, it did not blow the fuse. So it is actually a bad contactor. But when I jumper it here, it doesn't give us a problem. I think because the contactor is actually able to suck in. But somehow the slight voltage drop of going up to the thermostat and back down with the condition of this coil, it's just drawing too much, which is super weird. Never seen that happen before. We're gonna go ahead and kill the power to this thing though and swap out that contactor. Then we should be good to go. So 74 in here, set to 67, says wait, so it'll probably be about 5 minutes before it'll turn it on again. Just for fun, here's a brand new contactor coil. Here's that one we just took out. Let's just see what the ohm rating is. Ohm rating on this coil is 11.6, which actually doesn't look bad to me. I don't really know why. 14.3 on this one. There's slightly different styles though, so that could be... The contactor coil does have kind of a darker strip in it, so maybe it was heating right here. It's got a little area that's darker. I don't know how well you can see that, but weird. So we'll just see if it blows the fuse again, and we know we've got something else going on. So in case we have something else that's going on, we're going to try to watch the amp draw when it kicks on, but first we'll check the voltage between the C and the Y1, because that's where the thermostat will be sending the voltage. If we're getting a full voltage between C and Y1, we'll quickly switch this over to amps, because something is drawing 5 amps, and we need to figure out what. Although we know it's not the contactor, so we should probably check. So C to Y1, we're getting a full 27 volts. There we go. Drawing 0.67, so, oh, oops. Drawing about 1/3 of an amp. So I think that was all that was going on, but for some reason, when the voltage would feed through the thermostat, it would blow the fuse, and when I would jumper it here, it would not blow the fuse, even though it was this contactor. So that was kind of an interesting troubleshooting, because I thought it was going to be that contactor, and then it didn't look like it was that contactor when I was jumpering here. For some reason, it needs to be fed through the thermostat, so it's good that I checked it on the thermostat too, instead of just saying, well, it works, and then leaving. So looks like we're going to be good to go on this one. Hope you enjoyed, and I'll talk to you in the next video. Hydron.